All right, this is a seemingly intimidating problem when you look at it at first. So we have a cylinder whose height is 5 pi and whose base has radius square root of 5. And we're asked to find the shortest path around the cylinder. Not to find the shortest path, to find the length of the shortest path around the cylinder. Okay, so there's a little trick that you kind of need to know. So I'm emphasizing the circular base there. And you might think about this trick if somebody asks you to figure out the surface area of the cylinder. So the trick is we're going to cut
Open a cylinder?
along that line. Well, think about what if instead of this being a cylinder, what if this was like a soup can and it was covered with a piece of paper? Okay, there's no big deal to cut along this line and like peel off the piece of paper.
No.
Okay, so maybe you can visualize it like that. What happens after we do that? What's gonna happen is we're going to have a rectangle.
Yay.
And we're going to label this point in the upper left A, and the point in the lower right B. Okay? And hopefully on the rectangle it's clear what the shortest path is. It's the diagonal.
Yeah.
Okay.
But
Now,
that doesn't help us, does
that
it?
doesn't help us. I don't know. If I was thinking about this surface area, then I would want the length of the bottom of the rectangle and the height. And now they tell us the height. The height is 5 pi. So the question is, what is the length of the bottom? And the answer to that question is, what is the circumference? Well, the answer to that question is the same as the answer to the question, what is the circumference of the base? Because the circumference of the base is exactly this length down here.
Okay.
Does that make sense?
Yes.
That was a tentative yes.
Yes.
Think about what happens when I put this cylinder back together. Is
Oh no. The cylinder's good.
I've got I've got a base down here. Whoops. I'm moving the picture everywhere. I've got a base down here, and as I put the cylinder back together, all of these points on the bottom exactly match up with points on the base.
So
Okay.
basically, these 3 points here are the same here because this would literally just wrap around to
Right.
form this one right here
Yeah.
and make
Okay.
these 3 points.
So that means the length of the bottom there is going to be something like 2 pi r, where r is the radius of the base. Conveniently enough, they told us what that is. That's 2 pi times the square root of 5.
Okay.
Now, this is a problem for who? This is a problem for Pythagoras, right? Because we can say
Hi, Pythagoras.
this triangle right here,
It's right.
or the other one, it's a right triangle, right? And
Or this one is too.
sure, they're the same or congruent at least.
Except flipped, but
The
yeah.
math we need then is 5 pi squared plus 2 pi root 5
this length. What's that length squared?
squared equals the mystery distance
Okay.
squared. Okay.
This would be 25 pi squared.
Okay. 25 pi squared plus
Plus 4 pi times 5, so 20 pi.
20 pi squared equals d squared.
Sure.
And it's a little messy.
And then you could add
Here, I'll let
these two,
So,
making 45 pi squared is equal to d squared.
okay. Now what? We need D, right? Radical, both sides.
Square root.
Okay.
45. What's the square root of 45? I can't think of that right now.
Well, there's no simple square root
There's
of
no
45.
simple.
We would recognize it if it was. It's not 49. It's not 36.
It's certainly not 36.
Well, I mean, I'm saying 49 and 36 are 6 squared and 7 squared.
Uh-huh.
So the square root of 45 lies somewhere in the abyss between 6 and 7.
It's an abyss. No.
Many decimal points involved. Oh, you are a step ahead of me, so you know exactly what's going on. That was 3 root 3? You meant to write 3 root 5.
Oh,
Uh-oh.
that was bad.
Okay, we'll leave it here. I'm going to,
That's 3 root 5.
yes, I'm going to write it better. I'll
Okay.
write it right here.
Good idea.
So you, having less experience, 3 root 5 pi equals D. And the way we got that was we took the square root of 45 pi squared. And 45, of course, is 9 times 5. 9 has a nice clean square root
That is
of
nice.
3. Okay, and that's it. And the whole mystery of this problem is completely solved.
It's not completely so much
Right.
of a mystery anymore.
Once you realize the trick of opening the cylinder up, you realize what's going on. And I mentioned surface area at the beginning. This is how you figure out the surface area.
So now that we have that,
I mean, that's game over. That's the question, right? The question was 3
See.
pi root 5. Yeah. The surface area of a cylinder is going to be, if I have a cylinder of radius r and height h, the surface area is going to be 2 pi r times h.
whoa, what was that?
That's the area of this thing, right here. And then plus, I've got 2 circles, one on the top and one on the bottom. So that's 2 pi r squared.
Okay.
Okay, so that's just connecting to the very beginning when I said, what if you wanted to know the surface area of this thing? You might want to cut it open. You know, because maybe it's a soup can, and maybe you want to cover it with some paper, and what's the area of that paper?
I want to cover
Okay.
it with purple paper. And
Okay, all right, so that one's kind of easy in the end.
Yeah.